Okay, we've got an alternator connected up here to at 122.08 volt to our load bank. I'm going to get it running up to speed and at proper voltage, and then we're going to put some resistive load on it and some inductive load on it and see what happens to our output voltages. And so we've got a ammeter here to check the current going to the load, the AC current. We've got a meter here set to hertz so we can monitor the speed of this machine, and then we got our voltmeter here measuring the output voltage of the alternator. We also have a DC ammeter here which is going to measure the power input from the prime mover. Our prime mover today is a shunt connected DC motor because they have good speed regulation. We're going to use that for this lab, so I'm going to start bringing this up to speed. Volts. We've got our prime mover speed set at 60 hertz, 59.97. See if we can get it exact, maybe not. Oh, 60.1, 60 hertz. We've only got 8 volts of 8 volts being generated so far. That's just due to residual magnetism on the field poles. So I'm going to energize the field. And as we start applying voltage to those field coils, you'll see our terminal voltage come up. We're aiming for 208 volts. So we drop speed just a little bit. That back up to 60 hertz, which of course makes our voltage come up a little bit. So really finicky here. Can't quite seem to hit. So let's call it we'll call it 209 volts, 60 hertz. Our prime mover is consuming 4 amps of current at 125 volts. We'll calculate the power coming in. So we're going to add some load to this system. They're supposed to be an amp each. So our line current is 1.1 amp. Our output voltage is 203 and our hertz have dropped down to 59. Our current's gone up to about 7 amps. Add some more load on here. We're up to 3 amps of current on our output, 12 amps of current going into our prime mover. Our output voltage has dropped to 194, and our hertz have dropped to 57.9. That's not helpful. And that was at 3 amps of current. We're going to add some more in here. So that's taken our current up to 4.6. Let's get it up to 5 if we can. There's 5 amps of current. Our hertz is at 58 hertz. Our terminal voltage has dropped to 184.3, and we're up to drawing 18 amps of current from our prime mover. So that's as far as I'm going to go. So with our highly resistive load, our prime mover is taking quite a bit more power. Now if I want to bring this back up, if I try to bring this back up to speed, we increase the power to the prime mover a little bit. Back up to 60 hertz. We're just over 18 amps, and our voltage has come up to 189 volts. Okay, let's dump off the resistive load. Our current to our motors come back down to 4. I'd sped that up a little bit to get it back, so we're going to get us back down to 60 hertz. I'd never touched the field excitation in that as we were loading that up. We kept our same generated voltage, and this is just to show the voltage drop within the machine. So we'll get it back to 60 hertz. Again, we're sitting about 210 volts. See if we can get it down to 208, closer to 208. These are not precision machines by any means. And let's face it, in the field, if it was 209 and you were aiming for 208, you'd probably be okay. Now we're going to add some inductive load on this system. So that's our inductors here. So that's 0.9, about 1 amp of inductive load. Our voltage has dropped by 9 volts. Our hertz hasn't changed. We'll add some more inductive load. We're up to 2.5 amps of inductive load. Our voltage has dropped to 179 volts. Our hertz is staying the same, and our prime mover current is still staying the same. We'll add some more inductive load yet. At 3.4 amps of inductive load, still the same power come to the prime mover. Our voltage has dropped down to 158. Hertz still staying the same. We'll load it right up here. So now we've got 5 amps of inductive load. Our current to our prime mover is still the same. Our voltage has dropped all the way down to 127, and the speed of that motor is staying the same, right? Same input power, same speed. Nothing's been affected there. The biggest change we've seen is our terminal voltage. Now if we wanted to try to bring that voltage back up, I don't know if we can without popping the fuse, but we're going to increase our field current now to get us back up to the 208 volts. We've absolutely maxed out our field current at 2.5 amps, so I'm going to have to take that back down. But that's how you would normally run about 1.5. Okay, so that's how you would overcome that inductive load, is by increasing your field current. We never did really see much of an effect on our input power. There was a little bit, when I boosted the field current back up, we had a little bit more current, but really negligible in comparison to what it was with a resistive load. And that's the effects of putting resistive and inductive loads on a alternator.